Okay, recording in progress. Today is the 13th of September, 2023. Let's take a look at the syllabus. We are writing here. Okay, last time I assigned the groups, right? I told you about the CL, and the graph was actually here. Graph that actually was here, right? The previous one, X units, dimensional analysis. Okay, and see lab setup Excel graphs. Let's put it this way. What we're going to talk about today is going to be the significant figures, which is going to be important for lab 1. If we have time, we do lab 1. Otherwise, we leave for next week. Okay. Most likely, we won't have time to do lab 1, but at least you become familiar with the process that you have to use for reporting measurements. And anybody else here? Let's see. Good. Let's take a look at the notes right here. And I have, those are the notes for last semester. Okay, so just recapping, summarizing what we did so far. Summarizing what we did so far. How to put together, right? How to put together a table. Put together a table of data in Excel. How to plot your data in a graph using Excel. How to label the axes of your graph. How to adjust the units along the axis. Okay, how to display the trend line regression equation of your graph. How to display the R-squared value of your graph. And let's do it this way. In addition to that, I assigned you to groups. I also assigned you to lab groups. Oh, what else? You know? Yeah, how to find the confidence level of a regression equation with respect to its set of data points. So at this point in time, you should know, CL, that's what we call the CL. You should know how to use the CL. Okay. So what we are going to do now, what we're going to do today is to familiarize you with the proper reporting of measurements and results. Okay, there is a difference. Don't forget, there is a difference between measurements or raw data and results. Okay, measurements are obtained directly from an instrument, from a measuring instrument. Okay, and this measuring instrument can be a ruler, can be a scale, can be a multimeter. You're not familiar with that, but you should be familiar with ruler and scales. And also there are other ways of making measurements of length. Ruler, vernier caliper. Okay, vernier caliper is another instrument that's used to make measurement. Micrometer, right, is another instrument that's used to make measurements of length, scale, multimeter, etc. Those measurements generate what we call the raw data of an experiment. Okay. Results are the processing of the raw data. Okay. A measurement. Let me write it down here. Measurements. Types of measurements. Here you go. I want to give examples of the types of measurements. Length of an object. Okay, mass of an object. Temperature, okay, of an object, etc. And then what are results? Results are the numbers. Let's say, let's put it this way, are operations. Let's see, are operations of a set of measurements. Okay, when you operate in a measurement, when you make, let's see, when you make a numerical operation, right, of a set of measurements, you have the result. Example of results. Okay. Area of an object. Okay. Obtained whenever you make measurements of determined lengths of an object, right? That's what you don't. In this case, you can perfectly measure, for instance, the size of a square, right? And determine the area of the object. You can operate on the size of the object and determine the area. Okay, so let's see examples of results. Area of a rectangle, right? Here you go. Example of results. I'm gonna put, here you go. I'm gonna itemize them one by one. Area of a rectangle. You may measure the sides of the rectangle with a ruler, and then you multiply these sides to obtain the area of the object. This is a result. This is a result. Okay. Perimeter of an object. Perimeter of a rectangle, for instance. Another type of result. You make measurements, okay? You make measurements of the you make measurements, okay, of the size of the rectangle, and here you go with a ruler. The ruler, and then you sum all sides to obtain the perimeter. The perimeter is a result. Is a result. That's volume, right? Volume of a cube, for instance. You measure the size of the cube and multiply them. Multiply them to obtain the volume, etc. And there's a bunch of other measurements that you may have. Okay. 11 students so far. So let's practice that with an actual data that I'm going to distribute to you. Okay, I will provide you today, today I will provide you with an Excel data sheet. And we will work on this Excel data sheet. The first thing that we are going to see is going to be what significant figures. Significant figures, okay? Significant figures applies to measurements and results. And there is a difference between significant figures and a mathematical number, okay? That is an important difference between significant figures. Significant figures, I'm going to abbreviate it by SF, and mathematical numbers. Okay. In math, okay, the number one, for instance, is assumed to have what we called an infinite precision, or an infinite number of significant figures. Okay, in mathematics, that's a very important difference. So the number one can be the following equality for the number one can be written in mathematics. Okay, the number one can be written as being equal to 1.000 1, 2, 3. Okay, a bunch of zeros following this value. Okay. In physics, on the other hand, On the other hand, a measurement, this equality, on the other hand, this equality does not apply for a given measurement, okay? On the other hand, in physics, the equality does not apply for a given measurement. In other words, in physics, in physics, I'm going to insert an equation here. One is not equal to 1.00, okay? They're different. And that's the very principle of significant figures. And that's the very, and that is the very principle of significant figures. Think about that. Chew a little bit on that. Let this idea settle in your mind. Okay. There is an important difference between significant figures and mathematical numbers. In math, the number 1 is assumed to have an infinite precision or an infinite number of significant figures. In other words, the following equality applies in math. This equality here. And I'm not going to put this parenthesis here, that becomes very strange, right? Here you go. Okay, and then I'm gonna in math, right? The number 1. On the other hand, here you go. On the other hand, in physics, this equality doesn't apply for a given measurement. 1 is not necessarily equal to 1.00. In reality, 1 is different of 1.00. And this is the very principle of significant figures. This is the very core idea, right? This is the very core idea of significant figures. And let's see how this idea of significant figures apply. Think a little bit about that. Okay. So the question is, how do we use significant figures? Okay, significant figures. Okay, significant figures is a representation of significant figures. Let's see, has within it the information of the resolution of a given instrument. That's what you have to keep in mind. Significant figures as applied to a given measurement, okay? Not to a given result. And then I'm gonna write that down here. There are significant figures for a measurement and for results. Okay? So significant figures of measurements. Let's put it this way. the number of significant figures of a measurement reflects the resolution of a given instrument, of the measuring instrument that you use, okay? That's what you have to keep in mind. So in this course, we will use the resolution of an instrument, the resolution, or what do I mean by resolution? Or the minimum, or the smallest division of an instrument in the determination of the significant figures of a measurement obtained with this instrument. Okay, like that. The measurement. Resolution. And what is the resolution? The resolution is the smallest division of an instrument. Okay. So let me give an example. Let me see if I have, in the case of a ruler, for instance, let's see, let me get my PowerPoint here. Here we go. Let's see this one here. Okay, here you go. Here we have an illustration of a ruler. Okay, I'm going to eliminate this guy here so you don't mix it up. So here what I have a ruler. Okay. Regular rulers out there, they have this minimum division that's given in millimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, right? So in the case of a ruler, most rulers, right? The resolution of the ruler is going to be 1 millimeter. Let me show you an actual ruler here. I have one here somewhere, but since I cannot find, I'm gonna go there in the internet to show you. Here you go. Rulers, illustration of a ruler. Here you go. This one. Let's take a look. This one. Yeah, you can see it. Can we? Cannot. Okay, so you can see that the smallest division of the ruler in this case is going to be a millimeter, right? Don't forget, we are always dealing with SI units. Here is why they put 1 here. They're supposed to put 0 here. This illustration of the ruler is terrible. Let's take a look at another one. Let's see. Yeah, they put 1 here, right? Isn't that funny? Maybe this one. Let's see. No, not this one is the same. What about this one? Yeah, this one is better. You see what they did here? They start with the number 1 here on the leftmost side, right? Don't be fooled by that. Rulers are not like that. Rulers starts at 0. This one, here you go. This is a ruler here. Here's 0, 1 centimeter, 2 centimeter, and so on, right? Centimeter. For most rulers, and there are rulers that are different, okay? But for most rulers, the smallest division is 1 millimeters, 1 millimeter, right? So we start with the resolution of the ruler, which is, don't forget, the smallest division. For the sake of this course, we are going to use a ruler resolution of 1 millimeter. and the smallest division is 1 millimeter. According to the rule of significant figure, a given measurement made with a ruler should be expressed only up to the millimeter. Okay? The example is going to come next. Okay. Example. You make the measurement, a length measurement with a ruler. Which is 1.3 centimeters. That is the correct way of expressing your measurement, okay? Because of the resolution of this device, okay? It would be incorrect to express this measurement as 1.30 centimeters or 1.300 centimeters. Okay? And so on. There's an important difference between a measurement and a mathematical number. Okay? So going back here to Ridwan's link, right? This one here. But then we have other types of measurement devices too. But then we have other types of measurement of devices, other types of devices that measures length. Okay? One of them is the vernier caliper. Okay, the vernier calipers, we have at the college has a resolution of 0.1 millimeters. Although there are vernier calipers that have better resolution than that. Okay? Let's take a look at the vernier caliper. Before we go to an actual picture of vernier caliper, I'm going to show you how vernier calipers look like. They look like that. Okay, it is made of a ruler, a simple ruler, and then we have a second smaller ruler with a zero here. See the zero here? That's what we call the vernier. Okay, and as we slide, we slide. Oh, let me get that. Something here is not working as okay. Let's see the 02, right? Nope. Let's see here. Group. Yeah, group. As I open it, it's just like a little jaw, right? As I open it, this aperture here tells you the length of the device. But there is more to this ruler, okay? At this very moment here, we have like a 3 millimeter gap between this jaw, within this jaw, okay? But there is more to that. I covered, there's another scale here behind that I'm covering, and this scale looks just like that, okay? If you're not familiar with vernier calipers, you should be learning about that right now, because we're going to be using in our first experiment. Note, see that whereas, don't forget, a vernier caliper is made up of two different rulers. One ruler, which is a regular ruler, this one right in here, or whatever you see right in here. But then it has a second scale. It's made of two scales, right? One scale is your regular ruler, and the other scale is what we call the vernier scale. This is smaller ruler that you see right in here. Now you should understand a very important difference between this scale and this other scale. Okay? This is the type of device that was invented by a Portuguese called Nunes. And later on, a French guy picked up on his idea and improved it. And then instead of calling this scale the Nunes scale, today we call it the Vernier scale, right? Talk about stealing someone else's idea, right? The French did that. Okay, during the time of navigation, right? Portugal was the largest superpower in Europe, and this navigator and mathematician Nunes, he managed to invent something that later on became the Vernier scale. But let's take a look at this Vernier scale here, and let's see how it works, right? You can see that the separation of this scale here, the minimum division of this scale here is less than 1 millimeter, right? Can you see that? You can see that this line here is not lining up with this one. If it were lining up with this other one at the top, it should mean that this division here in the Vernier scale would be exactly 1 millimeter, but it's not. And that's how, and the scale was built in this way on purpose. Okay? Each of those divisions here has exactly the same separation as this one here. And if you look overall, the length from 0 to 10 is not 10 millimeters, it is 9 millimeters. A very important feature of the Vernier scale. Okay? That's a very important feature of the Vernier scale. Well, no, a little bit less, right? You go. Very important feature. This note, see that this zero matches, the zero below matches exactly the zero above, right? And the 10 below matches exactly the 9 millimeter here in the regular scale, which means that this gap here is exactly 0. And it is exactly because of this difference of a tenth of a millimeter that the vernier caliper allows you to make measurements with a resolution of 0.1 millimeters. Okay, let's take a look here. And I'm going to document everything that I mentioned here to you. You have to become familiar with the vernier caliper. And I have a vernier caliper here, fancier than this one. Let me see if I can find it in the internet before I document everything. Here you go, vernier caliper, illustration of a vernier caliper. Here you go. Like that. Here you go. Looks just like that. Vernier caliper. This vernier caliper is a little bit fancier because the vernier scale, see, has more divisions than the other one that I illustrate to you, okay? But here is one jaw, right? And that's the other one. And this is fixed jaw and movable jaw. This one is a movable jaw, which is my movable jaw is this one right in here, right? In the illustration there, this movable jaw is longer than the one I illustrated here. And I don't want to give you this link because that's not the link of the vernier this one that I want. Okay. Okay, I'm gonna give you a link following, read one's example. Here you go, right in here. And I'm going to send the link, vernier caliper link. This one. Let's see, I can, I'm going to save this image and then I'm going to this one here. I'll be able to zoom in and zoom out more easily, right? Here you go. Yep. Okay. Doesn't have a good resolution. The image doesn't have a good resolution, right? But here, just like I told you, right? This part of the vernier caliper is just like their regular ruler. Okay, and this part of the vernier caliper is the vernier scale. Okay, 1, 2, 3, 4, 5, 10, 10 divisions. The main division here is 1 millimeter. The division here in the vernier caliper, in the vernier scale, is not 1 division, it's 0.9 millimeters. That's how it looks like. And I'm going to give you an example how we use it. But before we use it, okay, a vernier caliper is made of 2 important scales. The main scale, which is the scale of a regular ruler with a resolution of 1 millimeter. The main scale and the vernier scale. Okay. The main scale. The main scale is just like the scale of a regular ruler with a resolution of 1 millimeter. The vernier scale in the simplest vernier caliper, the vernier scale has only 10 divisions. We're going to worry about this one. 10 divisions. Each division is separated by 0.9 millimeters. Remember that? So there is this difference. The difference between the two scales is 1 millimeter minus 0.9 millimeters, which, by the way, is equal to 0.1 millimeters. Okay? Or the resolution of the vernier caliper. Of the resolution of the vernier caliper. Don't forget, in the simple vernier caliper, we have vernier calipers that are more complicated than that. And you saw, right? Here in this course, we're just worried about the simple vernier caliper. Notice that this other vernier caliper here, the vernier scale doesn't have 10 divisions, has more, right? Has 10, 20, 30, looks like it has 40. Okay, so we can have vernier caliper with this many divisions as well. That will result in a larger resolution, but don't worry about those more complicated ones, okay? I want you to concentrate on this type of vernier scale, on this type of vernier caliper. Let me show you my own vernier caliper, real life vernier caliper, right? If you want to see a real life vernier caliper, you can also, let's see, I want to see an actual pic. Here you go. That's the picture of a real life vernier caliper. This vernier caliper is just like a fancy one. Let's say 1, 2, 3. He has a longer, the vernier scale is longer than the other one. When you have a vernier scale longer than the other one, you have a higher resolution as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See that? It's 10 units of separation, but it's longer. Okay? It's longer than the other case. Let's see if I want a picture. That seems like to be a picture. No, it's not a picture. This is a drawing. Okay, here's a rule.
Cuidado ou proteção? Escolha os dois.
Let's see, skip that, right?
A diferença desde o primeiro uso.
Okay, here you go. Ruler. He's drawing a vernier caliper. I'm gonna send you. If you want to draw a vernier caliper, he's showing you how to draw a vernier caliper. How to draw a vernier caliper. Good. That's the movable jaw, right? That's the fixed jaw. Let's see if I can go faster than that. I don't want to wait too long. Let's see, here you go. The important thing about vernier caliper is to memorize that it's made of two important scales, right? The ruler, the scale of the ruler, 1 millimeter of resolution, and the scale of the vernier scale with spacing, a division of 0.9 millimeters. When those two scales work in conjunction, you can get measurements of 0.1 with a resolution of 0.1 millimeter. It's taking too long. Let's go faster than that. Yeah. This jaw here is used to make measurements, outer measurements or outer diameter measurements. These other two features here that you see here is used to make measurements of inner diameters. Okay, you can make the measurement of a hole using those two features here in the vernier scale. Okay, this other feature that he drew, let's go back a little bit. This other feature that he drew here at the, let's go back. This other feature that he drew here at the extreme right is a feature that's used to make measurements of depth measurements. Okay, depth measurement. That's what this one is used for. So depth measurement, inner diameter, outer diameter. Here you go. Outer diameter, right? Diameter of a disc. Here's the divisions. Centimeter division. Here you go. That's the vernier scale. Here you go. He's putting the millimeters in there. It may be lots of work, but if you do something like that, you start to understand better how the device works. Okay. This vernier scale seems to have like 20 divisions. 5, 10, 15, right? 20. Oh no, wait a minute. No, this is the centimeter. It's not the vernier scale. It's just a window. See, it's just a window for you to see the regular scale. Okay, the vernier scale he's gonna draw elsewhere. Shadings, right? Very soon I will write down what you need to know about that, about the vernier scale. If everyone's having troubles, the last link. Oh, cool. Thank you. Thank you, everyone. He didn't draw the vernier scale yet. I think he's gonna do that. Oh, okay, here you go. Now he drew the vernier scale. Okay. It doesn't show him drawing, right? The vernier scale. Yeah, it doesn't show him drawing the vernier scale. Here you go. Good. So stop it. Let's go back here. So let's write it down. What simple vernier caliper. In the simple vernier caliper, vernier scale has only 10 divisions. Each division is separated at 0.9 millimeters. The difference between the two scales is 1 millimeter minus 0.9, which is a tenth of a millimeter, or the resolution of the vernier caliper. Okay. And there are simulations out there. Let me show you a simulation of a vernier caliper, how it is used. The only thing I don't like the simulations on the vernier caliper is that they don't have, I have never been able to find a simulation of the sampled vernier caliper, okay? Simulation of a vernier caliper, you go. Oh, they have a FAT. Let's take a look here. FAT. Vernier caliper simulation. FAT. Let's see here. Let's go circle vernier caliper simulator. Where's the FAT? FAT. No, that's pH scale, not what I want. Huh. Yeah, okay, let's take a look. For some reason, here you go. This is the, this is a vernier caliper with 20 divisions. It's a longer, it's a longer vernier scale. Vernier scale with 20 divisions, then a longer one. And this guy came up with the simulation. Let's see if we can. This one has a 0.02 millimeter resolution exactly because of this fancy vernier scale that we have here. Okay. Let's see if I can get, oh, here you go. That's the one. And I want to stop this guy. Okay, here you go. You open and close, right? Close and open. Here's, you have a 0 length. And here you have, let's see if I can get exactly 1 millimeter. I cannot get exactly 1 millimeter. And 1.04, okay? And how do you get 1.04 millimeters? You know, you count how many, you know, you look at which line in the vernier scale, which line combines, is lined up with the other main scale. Okay, so you can have the zeros indicating 1 millimeter plus something else. And this something else you determine by counting how many divisions you have from here to this point. 1, 2, 3, 4, 1.04. Okay, 1.04 millimeters. That's how the vernier scale works. It's 9:47 right now. Let me take attendance and let me also post this one. Okay, here you go. Like I mentioned to you, I prefer to use the samples vernier scale, the vernier caliper, but they don't have simulations out there in the internet with the vernier caliper that has a 0.1 resolution for some reason. Vernier caliper simulator, must be this one here. Here you go. Maybe this one, vernier caliper simulator. Let's see, let's hope. No, this one is not 0.1, is it? Oh yeah, this one is 0.1. Okay, good. Okay, good. This must be a recent simulator. What we have here, 0, 1 centimeter, 2 centimeters, 3 centimeters, and so on, right? 1 millimeter, 2 millimeters, 3 millimeters, 4, 5 millimeters. And take a look at the vernier scales, only 10 divisions, right? All those 10 divisions has a length of 9 millimeters. When you manufacture an instrument like that, you can make measurements with a resolution of 0.1 millimeters. So how do you do that? If I'm gonna open this, I'm gonna try to open exactly half centimeter or 5 millimeter. Okay, let's see if I can do that. Let's see if I can. Oh yeah, I can use the good. Okay. So what we have here? I have the 0 is lined up with 5 millimeters, perfectly lined up with 5 millimeters. If you want to make sure that the 0 is perfectly lined up with 5 millimeters, just look at the 10th division here, right? It's also lined up with the upper scale. So this measurement that you have here should be reported as being 5.0 millimeters, okay? And let me, use the simulator here. Use this simulator here to understand how a vernier caliper with a 0.1 millimeter resolution works. Okay, this one is the one I should be using. Okay, so let me decrease the size. Very soon when I have our break, here you go. I'm gonna copy and paste here. Copy this guy and paste it into my notes. Snipping tool. Has anybody ever used the vernier caliper in their day-to-day life here? I want to hear from you. Anybody here in this classroom has ever used a vernier caliper? Just for fun, In the above, this measurement is supposed to be reported as 5.0 millimeters. Okay, you gotta put the 0 here. You don't report it as 5 millimeters. You report as 5.0. Haven't had it to us yet. Okay. Okay. Now let me give you another example. Here you go. I have my own vernier caliper. I'm gonna show to you when you come back from the break. Okay. Let me see. Move this guy. Yeah. Now I'm going to move just a little bit. Okay. Move this vernier. Let's see if I can. I cannot zoom it. Zoom it. Yeah, I cannot zoom it. Notice it that now that this length here is going to be 5 millimeters plus something else, right? And again, I'm going to copy this image. I'm going to paste it there in my notes. And we're going to analyze it clearly, carefully. We go. No, I want something better than that. Let's do it again. I remember that I'm using a snipping tool in Windows. Notice here this region, right, to measure the depth, to measure a given depth. This one. In this measurement, okay. In this measurement, we have 5 millimeters. I'm gonna even write it down. 5.0 millimeters plus something else, right? Something else. This little something else here, this little difference here that you see from 0.5 to the 0 of the vernier scale. How do we find out this something else? How do we find out this something else? Okay. Okay, you look here at the line of the vernier scale, the line that coincides, that's lined up with the line of the main scale. You can see that's going to be the seventh line, right? Since the seventh line on the vernier scale is lined up with the main scale, the correct measurement is supposed to be reported as 5.7 millimeters. Okay. 5.7 millimeters. And I'm going to emphasize, and those are the significant figures of this measurement. In both cases, we have two significant figures in the measurements. Okay. Another student trying to come in. Two significant figures in the measurement. 954. Any questions about that? Let me save it. You have the link for that. I'm going to copy and paste it. Okay. The figures can be found in the link. Here you go. Okay. And then let me give you another example before we move to our break. Let me give you another example. I want to give you this example because sometimes people, what's going on here? Okay, here you go. Here's another example of a measurement. Okay. So we have 1 centimeter, right? I'm gonna copy that. One centimeter plus something else, right? And people sometimes become confused about Hegel. In this case, we have 1.00 centimeters, right? Plus something else, right? Here is centimeter, here is millimeter, here is a tenth of a millimeter, which, by the way, can be written as being 10.0 millimeters. Okay? If this measurement has 3 significant figures, this other measurement must also have 3 significant figures. Okay? Was this something else? Let's zoom in here in this figure. So when I do my lab, we do exactly that, but we take a picture with the phone and zoom in the scale, okay? You know, the first line is not lined up, right? The second one is not, the third one is not, the fourth is not lined up, but it's getting closer and closer to this main line, right? And look what happens. The fifth line is lined up and the sixth is off. So this measurement, this something else is going to be what? This something else is 0.5 millimeters. And the resulting measurement is 1.05 centimeter, which, by the way, is equal to 10.5 millimeters. In both cases, we have 3 significant figures. Okay, in this case, we have 3 significant figures. Significant figures, capital S. Hey, go, did I choose significant figures, right? And in this case, we also have 2 significant figures. And don't forget, outer diameter, inner diameter, and here is depth, right? And so that's one type of instrument that's another type of instrument that's used for scientific and engineering purposes. The ruler, right, that you're already familiar with, and then we have also the vernier caliper. Let's take a look here. Group. I'm going to freeze pane right in here. Good. And now I know. Oops. Go back here. Nazmoon. Is Nazmoon around? I'm taking attendance now. We have 12 students. I don't see Nazmoon there. Donovan. There was a student, Donovan, that was registered, but he didn't show up. And Tessa, are you there? Tessa is there, right? Okay. So you already told me. I just want to ask you all, folks, if you have used the vernier caliper, okay? Tessa said that haven't used yet, right, Tessa?
No, I've never used one.
Okay, good. So Destiny, have you ever used are you there first? If you're there, right, Destiny?
No, I never used one.
Never used one, okay. And next is Gael. Have you ever used a vernier caliper? And is Gael there? Gael Garcia? I can't hear from you, Gael, so here you go. I'm gonna put a star. Ridwan, you're there, right? And you haven't used, right, Ridwan? Okay, thank you. And Ashley, I don't see Ashley there. Ashley Zomo. Okay, no, Ashley. Annabelle, are you there, Annabelle? Annabelle, here's my list, but she's not answering. I'm gonna put star here on her name.
I'm here.
Oh, you're there. Okay, good. Have you ever used a vernier caliper before?
I have not.
Okay. And Norberto, are you there?
Yeah, I'm here.
Okay. Have you ever used a vernier caliper before?
I have not, but I've seen one before.
Oh, I have seen one. Yeah. Okay. So yeah, good. So good point, Norberto. Used. So there are two questions, right? That I want to make you. If you ever used and if you have ever seen, right? That's a good point. Used or seen, have ever seen one in your hand, right? I do not know. Norberto said yes, right? I do not know about the other students. Let's go back to Tessa. Have you ever seen one, Tessa? At least have you ever handled one in your hand?
I don't recall if
No?
I have ever.
Okay, good. And what about you, Destiny? Have you ever seen one in real life? Not just in pictures?
I think I have in
Yeah.
real life.
Yeah, where did you see it?
Like in the labs at school.
Oh, in the lab at school. Okay, good. Okay, yeah, we have a bunch there at the Lake Harbor. And Gael, are you there? Another opportunity for Gael to. Nope. Okay, read one. Have you ever seen one in real life? We have one at my family shop. Oh, cool. So they sell those things there at your shop, or they just use it? We just have okay, just your the shop that you have at your house, right? Okay, cool. Okay, and who used that? Your father used it. Who used that? Grandfather. Okay. Well, and what does he use that for? Now I'm curious. You know, what does he use it for? Did he use it for anything mechanical, or what's that? Well, you can answer later on. So let's move on here. Annabelle, have you ever seen one? He hasn't had it for it lately, but I'm not 100% sure. As we're in the marine electronics business. Uh-huh. Oh, okay. Okay, cool. Yeah, it's a nice instrument to have around, you know. I use it, my measurements. I have seen plumbers using them too. Interesting. Huh. Yeah, they most likely they're measuring the diameter of the pipes, right, Norberto? Yeah, interesting. I use it my experiments too if I want to make some measurements. Okay, and let's see, Annabelle. Have you ever seen one, Annabelle?
No.
No. Okay. And next one here is Vanessa. Are you there, Vanessa?
Yeah, I've used one once and then I've seen it being used.
Okay, so you said that you have seen once, right?
Yeah.
But you never used it, right?
I used it once in a biology class.
Oh, you used once in biology class. Okay, cool. And what were you measuring? What were you measuring in the biology class?
A bug, like a little black beetle.
Okay.
Yeah.
Okay. Man, gotta be careful not to crush it, right? Not to crush him, right?
Yeah.
Okay. Okay, thank you. And Camden, are you
Yes, I'm here.
have you ever seen a vernier caliper before?
Yes.
Oh, okay. Have you ever used one?
Yes.
Oh, okay. You have used for under what conditions? What was the situation that you were using it for?
So I took like same class as this one from different school, but I
Oh.
ended up like dropping the class. So we did their lab,
Okay.
and yeah, I used it before, but I don't remember how to like measuring. I mean, how to read it because I think there's like things to you like read and stuff, I think, right? You have to
Uh-huh.
like squeeze in, like read the first number and then the point number or something like that. I don't know.
Mhm.
Like
Yeah,
decimal numbers, right?
yeah, that's right. You can practice, right? You can practice with this simulator here, how to use it, and just take a look also the examples, right, that I posted here in the notes, right?
Yeah.
I have different examples here with the answers. So
Oh, okay.
all you have to do to find the last decimal place, you have to line up the lines of the vernier scale with the line of the fixed scale, right? The
Okay.
main scale. That's what you have to do. Okay, and
Professor, are you
yeah,
taking attendance right now?
yeah, I'm taking attendance right now. I'm taking attendance. See that? I'm taking attendance right now.
Oh, so I'm not absent, right? I didn't dismiss the class because I
Yeah,
came late.
that's okay. That's okay.
Oh,
And
okay. Thank you so
and
much.
so let me see if I understand. You took this class before, right, in another college, but you had to drop. That's how you became exposed to the vernier caliper, right?
Yes.
Okay. Cool. Which school was that?
El Camino College,
Oh, El
and
Camino College. Okay. Cool.
I also did the online class during the summer, with like the same class, but
Yeah.
I dropped it because like at the time I was taking like 5 classes at the time.
Okay. And the one at El Camino College was the online or was the
Oh, El Camino was like in person,
in person?
but yeah.
Okay. Oh, nice to know. Thank you. So next one is Victoria. Victoria, are you there? Victoria Preciado.
I'm here. I have not seen it or used it.
Are you okay? Cool. Okay, thank you. And Alexis? I don't see Alexis here. Okay. Next is going to be Marcos Sanchez. I haven't used one, but I have seen one. Okay, cool. You have seen one, but not used one. Okay, cool. Sky?
I haven't used one, but I have seen one.
Okay. And but I want to ask you I wonder what conditions you saw one.
I think probably just in a movie or a video or something.
Oh, really? I'm moving the video. Okay. Nice. Okay. And Eric, are you there, Eric? I don't see Eric here. And Catherine, right?
Yes, I'm here.
Yeah. Have you ever
Yes.
seen or used one?
Yes, actually, well, I've seen one because my dad has one, but I've never used it.
I never use it. Okay. Yeah. Okay. Yeah. Well, like I said, it's an important device. Okay. This the vernier scale date as far back as the 1500 when this Portuguese navigator and mathematician invented something similar, and then Vernier himself, which was a French guy, he improved on the invention of this Portuguese guy, and today we call it the Vernier caliper. Okay, this Vernier scale, by the way, is used not just in linear instruments like that, okay, but it's also used in rotating instruments too, okay? It can be adapted to different geometries. And stand 10 right now, I want to take a break and not this one. Oh, this one here. Okay, break 10:10 a.m. to 10:25 a.m. Okay, any questions? Don't have any questions. We can move to our break, and I see you in 15 minutes. Okay, so let's do the step by step here, how to use a vernier caliper, right? One, the vernier caliper has two scales. The main scale with a resolution of 1 millimeter, right? And the vernier scale with its separation, right, between lines of 0.9 millimeters. The simplest vernier scale. Remember, we're dealing with the simplest one. We're not gonna get into the more complicated one, okay? Clamp the object that needs to be measured between the two jaws of the vernier caliper. Okay. Start by measuring the length of the object by measure the length yeah, let's see, measure the length of the object in two different steps. Measure the length of the object in two different steps. Okay, A. First, read the value in millimeters or centimeters using the reference 0, right? On the vernier scale. B. Next, watch which line in the vernier scale lines up with the upper scale. And count how many lines this line is from the 0. Okay. Example. If it's well, let's leave this way. Okay. We already have an example down up there, and here's my vernier caliper. Hopefully I can. I'm going to stop sharing. You need to. Let's see here. I want to stop sharing here this window. Oh, here you go. Stop sharing. Good. And here's my vernier caliper. Okay. It's my vernier caliper has, 20 divisions, by the way, just like the other one, has a resolution of 0.05 millimeters. Let me see if I can. Let me stop. Okay, now we should have a better focus on this vernier caliper. Okay, so here you go. You can make outer diameters measurement. Here you go. Here's my coin, right? I want to measure the diameter of this coin. I clamp between those two jaws. Okay. If I want to make measurement of a hole, right? The length of a hole, like in this clipper of mine, what I have to do? I have to use this upper portion of my vernier caliper. Okay. Oops. Okay. And if I want to make depth measurement, let me get something here that I can measure the depth. Okay, let's see. This guy, this thing here that I have, this box that I have, right? I want to make a measurement of the depth of this box. Okay, and now I can even lock the vernier caliper into place. Here you go. This one is locked, and now I can make the measurement of this depth by looking at the scale, right? So 3 ways of using the vernier caliper. Okay, so you can make 3 types of measurement, right? Of measurements with the vernier caliper. Outer diameter, inner diameter, and depth measurements. Okay. So don't forget resolution. Resolution of the ruler, 0.1 centimeter, which is equal to 1 millimeter, which is equal to 0.001 meter. Right? So any measurement done with the ruler, let's say, example of a measurement, right? With the ruler. Example measurement with the ruler. Example measurement, 10.3 centimeters, which is equal to 103 millimeters, which is equal to 1.1, no, let's see, no, not 1 point, 0.103 meters. Note that those are all measurements made with the same device, but displayed in different units. In all, oh, yeah, I gotta share the screen, thank you. Three, here you go. Okay, you can make 3 types of measurements with the vernier caliper: outer diameter, inner diameter, and depth measurement. Resolution of the ruler is 0.1 centimeter, which by the way is equal to 1 millimeter, which by the way is equal to 0.001 meters. Example of a measurement, 10.3 centimeters, 103 millimeters, or 0.103 meters. Okay, 3 significant figures. 3 significant figures. Resolution, next one, resolution of the vernier caliper. It's not difficult to remember that, right? 0.001 1 centimeter, which is 0.1 millimeter, which by the way is 0.0001 meter. Right? Okay, so example for measurement. Use the example for measurement with the vernier caliper. Now, in this case of the vernier caliper, you should add a significant figure, right? Let's say something like that. Let's say you make a measurement, the same measurement that you made with the ruler. Now you're repeating with the vernier caliper. It's going to have an additional significant figure for SF, 3 SFs, right? Significant figure. Rules for significant, and by the way, rules for significant figure. Rules for significant figures. Zeros to the right of the zeros to the right of a non-zero digit is considered a significant digit. Okay. Zeros to the left, let's see, zeros to the right of the, you gotta put of the right most, zeros to the right of the rightmost as non-zero significant digit. Significant digit is considered a significant digit. Zeros to the left of the leftmost non-zero SF, significant digit, is not considered a significant digit. Okay. Example, right? Example. 1.30, 3 SF, right? 3 significant digits. 1.300, 4 SF. Huh? 1.30. Let's say this thing is like centimeters. This is centimeters. This is centimeters. Okay, you still have 3 SFs. Okay, because this 0 here is not considered a significant digit. And then we can repeat for the other one. 0, 1.300 is still 4 significant digits. This 0 here is not considered a significant digit. The zeros in boldface. The zeros in boldface are not considered significant digits, significant figures. Significant figures or significant digits, okay? I'm gonna write that down here. Significant figures is equal to significant digits. In this case, I call that SD. And then we have this other device called the micrometer. Micrometer. 3 different devices that are introduced to you in my lab, my physics lab. I'm gonna put my vernier caliper back into this, box. Okay. I bought this vernier caliper back in 2003. Okay, it's a mechanical vernier caliper. Some time ago, also I bought one of those electronic vernier calipers. They sell those things for $30, and the electronic vernier caliper of mine is already gone. So this one I have for 20 years already, didn't break down. The electronic vernier caliper lasts no more than 5 years. Okay, so and I had to throw it away. It was not battery problem because I changed the battery and the device still was not working. Okay, let me show you a micrometer. Here you go. I have a micrometer. It's micrometer of mine. Okay. And let me stop sharing so you can see better. Don't forget to tell me to start sharing again, right? Here you go. That's a micrometer. In this micrometer, you have the main scale. You have a main scale as well. Let me see. Okay, and I'm gonna show you if you can see well right now, I'm gonna show you a simulation of a micrometer. There are plenty of simulations out there of a micrometer, and micrometer simulator. Okay, here you go. The same guy that had the simulation of the vernier caliper, he made a simulation for the micrometer as well. Okay, virtual. Here you go. Okay, that's how it looks like. That's the main scale of the vernier of the micrometer, and that's the secondary scale of the micrometer.
Professor, I cannot see.
Oh yeah, thank you. Okay, here you go. And let me send you a link simulation of micrometer link, right? Here you go. Let's see if we can play a little bit more with that. Right in here. All right, here you go. Oops, stop, man. See, that's the micrometer. You have two jaws, just like before. This is the movable jaw. This is the fixed jaw. The problem with the micrometer is that you cannot make measurements longer than 25 millimeters, okay? Unless you build a very large micrometer. Let's see, I'm gonna move. Yeah, all the way up.
Wait, is this the standard model? Like a 25 millimeter is the standard model.
Yeah, that's right. Most micrometers are sold out there is 25 millimeters. You might be able to find larger than those, okay? But of course, they're going to be more expensive. Mine is 25 millimeters. The one I have here is 25 millimeters as well. But if you go out there in the internet, you might be able to find longer than those. Okay. So just like before, you have the main scale. See the main scale? That's just your regular ruler. From 0 to 25 with a resolution of 1 millimeter. But then this ruler is a fancy one. It has a second scale that goes half of a millimeter, right? 0, half of a millimeter. 1 millimeter, 1.5 millimeter. 2 millimeters, 2.5 millimeters, right? And then you have this rotating scale. This rotating scale is an interesting one. Basically, what we have here is a very fine thread. Okay, you can move it up and down. Look, the 0 in the rotating scale coincides with the horizontal line of the micrometer, right? And look what happens. Notice that this rotating scale has 50 divisions: 45, 46, 47, 48, 49, 50. Okay, 50 divisions, 50 angular divisions, right? And let's see what, and that's what gives you the resolution of the micrometer, provides you the resolution of the micrometer, okay? If I move exactly half millimeter, let's see if I can get that. No, 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 no. Stop it. Ay, 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 ay. Stop it. Let's see if I can move it. If I go exactly half millimeter, let's see if I can get that. Yeah. Yeah, it doesn't have, it's a little bit difficult to, yeah, to get exactly the half. Let's see. Wow. Let's see.
Professor,
Yeah.
what time are we going to start the lab?
Well, we already started the lab. This is
Oh,
the
this
lab.
is the,
Yeah,
oh,
this is
okay.
the lab. This is
But
the
when
lab.
are we going to like measuring, when are we going to measure?
Well, yeah, I'm going to provide you with the data very soon. Okay.
Oh, okay.
Okay, I'm going to provide you with the data very soon. So here you go. The now if I manage to line up the zero with the horizontal, okay, so this zero here is almost lined up with that, right? So you can see what we have here. We have a full rotation of this knob. A full rotation of this knob corresponds to half millimeter. Okay. If a full rotation of this knob corresponds to half millimeter or 0.50 millimeters, right? So one division corresponds to 0.01 millimeters. Okay. 0.01 times 50 is going to be half millimeter. That's how we get the resolution of the micrometer. Okay, so let's go here. And micrometer, resolution of the micrometer. Point 0.01 centimeters, 0.01 millimeters, or 0.000000001 meters. Okay. It's is the travel distance of each of those little notches in the rotating knob. Example of a measurement. So here you go. I can put it like that. 5 significant figures. Okay. So like the vernier caliper, the micrometer has a fixed jaw and a movable jaw. Okay. Like the ruler and the vernier caliper, the micrometer has the main scale with a 1 millimeter division. Okay. Unlike the ruler and the vernier caliper, the micrometer has a second scale at half millimeter, 1.5 millimeter, 2.5 millimeter, etc. Okay. Unlike the ruler, and the vernier caliper, the micrometer has a third scale. This third scale is a rotating one. Rotating one. With 50 divisions. Okay. A full rotation of this scale corresponds to a linear distance of 0.5 millimeter. Consequently, each division of the rotating scale corresponds to a linear distance of 0.01 millimeters. Okay? Fancier micrometers have a force scale. Force scale. I'm going to show you. Which is a vernier scale attached to the rotating knob. Okay. This force scale allows for a resolution of 0.001 millimeters. Okay, not every micrometer has this 40 scale, okay? Only very fancy ones. Mine, I was fortunate to purchase a micrometer that has this vernier scale here. And let me show you. You don't have to worry about that, okay? But it's nice to know. Yeah, right in here. Yeah. Take a look. Remember, right? Let me stop sharing again. I'm gonna stop sharing and don't forget to remind me in case I forget to share my screen again. Remember, right? We have this. Can you see it now nicely? Looks like it's out of focus, right? Let's see. You order immersive speaker. Let's see. Nope. Okay, let's see if we can get it. Can you see it? It's like it's out of focus, right? Well, I'm gonna take a picture and share that with you, okay? I'm gonna take a picture and share that with you. Next. My cell phone is here. Okay.
Professor, I have a question.
Yeah.
Do we have to submit the lab before the class is over, or
Now you have one week to submit the reports.
oh yeah, we have to submit the report before the class is over, right?
No, you have
No?
1 week to submit the reports. 1
Oh,
week.
okay, okay.
Okay. And well, I'm gonna get to that. And let's see.
I need to go to work, but I can stay in the Zoom meeting. But do we need to do some types of like group work in class or something?
Just like I said before, in order for you to get credit for the lab, you must be present all the time. Okay.
Yeah, I'm gonna be present, but I'll be like using cell phone though. Is that okay?
Well, it's like I said, you must be present. So if ideally you should be using a computer, okay, because it's very difficult to see the image in the cell phone. So
yeah, I can use the computer like it in like 10 minutes, I think.
Well, let's talk about that after the class, okay? So,
but I need to go now, so
okay, I'll keep a note that you had to go, okay? So let's
But I'll be in the Zoom meeting though, like with my cell phone. But that's going to take only like 10 minutes, and then I'll be using my computer again. Is that okay?
Yeah. Mhm.
Oh, okay. All right. Thank you so much. I'll be right back.
So let me get here. I cannot focus it. I'm trying to take a picture here of this vernier scale. Okay, looks like I got it. Yeah, okay, good. So it's not very nice. It's not, and this simulation here doesn't have this vernier scale, okay? But look at how, you know, with a little bit of imagination, right? How we can use old things in new configurations, right? Old things would be like the vernier scale. And now I'm going to share the screen here. Okay, here's my micrometer. Okay, here's the main scale: 0, 1, 2, 3, 4, 5, 6, 7, right? The other secondary scale is below here. We cannot see it. We see the third scale, the rotating scale, right? Each division here corresponds to 0.01 millimeters. And then finally, we have here the vernier scale for this rotating knob. Okay, we do have 10 divisions. We do 0, let's say, we do have 10 divisions here. Notice that it's a little bit difficult to see because it's not very well focused, but here you go. Yeah, 0 corresponds to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay? The principle is the same as the vernier scale of the vernier caliper. The only difference is that the vernier scale of the vernier caliper is linear, and the vernier scale of the micrometer is circular, just like you see here. And just like you have, 9 millimeters for 10 divisions of the vernier scale, here we have the same thing. We have 9 divisions in this rotating scale for 10 divisions in the vernier scale. Okay? And this vernier scale allows you a resolution that is 10 times better than the resolution without the vernier scale. Okay, so here you go. Okay, so without vernier scale, right? Without vernier scale. 0.01 millimeter with vernier scale. Resolution without vernier scale. Resolution without vernier scale. Resolution with vernier scale. 10 times better. And then there are other tricks that you can do to improve something like that, okay? But those are but we're not gonna cover those other tricks that are there out there. Just keep that in mind. Fancier micrometers. And okay, let's play the simulator. And I believe you already have the simulator, right? And so The simulator is this one right here. Okay. In this specific case, you have 0.5 millimeter, right? If I open, oh, let's see how. Okay, now I have a better resolution here. Yep. 49, yep. Right? Now, if I want, I'm gonna turn off the measurement. So here you go. I got one simple measurement here. Here you go. This measurement is simpler than the other ones. So what we have here, we have 10, 11, 12, 13 millimeters plus something else, right? In this example. In this example, my chronicle example. Okay. So what we have, first step, 13 millimeters plus something else. If you're going to report all the significant figures, you have to put the 00 there after the decimal place, right? And this something else is what? Something else you read from here, from this rotating knob, is the 39, 30, 35, 36, 37, 38, 39, right? So plus something else. This something else is 39 divided by 100 millimeters, which is equal to 0.39 millimeters. Okay, so the right measurement that you have to report is 13.30, oh, not 35, it's 39 millimeters for significant figures, right? And then the measurement becomes trickier when, let me show you a trickier measurement. I'm gonna go past the 0.5 millimeter mark, right? And then I'm gonna copy that. Here you go. And I will paste it in my notes. Here you go. Just like before. Oh, it's not like before. It's different than before, right? It is slightly different than before. Look at this line here of the rotating knob. It's past the 13 millimeter mark, right? But it's also past the 13.5 millimeter mark. So my measurement is going to be, my measurement will be 13.50 millimeters, right? Plus something else between this dash here and the edge of my rotating knob, plus something else, right? This something else is what? Just like before, we have, I'm gonna be a little bit, no. Yeah, it's gonna be, let's see, almost 44, right? It's almost 44, is 44 divided by 100 millimeters. So what you end up having, you're gonna end up having resulting in a final measurement of 13.94 millimeters for significant figures or significant digits. Okay. I want to make it exactly 14 millimeters. Let's go back to the simulation. Yeah, I need to use this one. 13, yeah, this one is more precise. I want to do that exactly 14 millimeters. This 0 here must line up with the horizontal line. And now I have exactly 14, 1, 2, 3, 4. I can open the eye here. This one here should be a small difference that I have. Okay, now I have exactly 14 millimeters. 14.00. Okay. Those are examples of how to use a micrometer. 3 different devices. 11, 10. Let's see how is our break. Okay, our last break was 11, 10, 10, 20. Okay, let's have our break now that we've finished. So 3 different devices, 3 different measuring devices. For the rest of this semester, you're going to use this resolution for the ruler, vernier caliper, and the micrometer. Measuring devices for the rest of the semester. Unless I tell you otherwise. Unless I tell you otherwise, we will use the following resolutions. Ruler, 0.1 millimeter. Vernier caliper, 0.01 millimeter. Micrometer, 0.001 millimeter. You'll be using those resolutions for the rest of the semester, okay? And any more questions? So let's see, I want to give a opportunity for Gael. Are you there, Gael? Let's see. Gael is not answering. I have 13 students now. Let's see. Someone else. Oh, okay, Gamden has 2. Okay, so we're in good shape here. And okay, so let's have our break from 11:10 a.m. to 11:25 a.m. Yeah,
Professor,
yeah.
I'm still here. I was just wondering what's going to happen because like I couldn't participate the class earlier today because like I wasn't there. I wasn't here, but the one of my classmate, I mean the group classmate explained to me about the lab and stuff. So thank you. I didn't mean to interrupt you during the class. I'm so sorry.
All right.
Thank
Okay.
you.
Welcome. Let me save it here and I'll see you in 15 minutes. I did. Okay, now we are recording here. I added one more illustration to the notes. Here you go. I added that picture that I showed to you of my of my micrometer. Okay, so let's summarize here, right? Summarizing. One, the ruler has just one scale, having a 1 millimeter, having several 1 millimeter divisions. Okay. Two, the vernier caliper has two scales, the main scale plus the vernier scale. Three, the micrometer has at least three scales, the main scale, the half millimeter scale, and the rotating scale with 50 divisions, right? A fourth scale vernier scale can be added to the micrometer to improve its resolution, right? The important thing here is that the vernier scale, important thing here, right? Important thing here is that the vernier scale can be adapted to the micrometer as well. And 11:30. Right, now we have another half hour. And one more thing that you have to know about this lab is in this lab, I will provide you with the measurements of the diameter of 6 steel spheres. Okay. I will provide you with the measurement of the diameter of 6 steel spheres, plus a measurement of their mass. The diameter of the spheres were measured with the ruler, the vernier caliper, and the micrometer. In other words, the diameter of the spheres was measured 3 times, each one with a different instrument, okay? The mass of the spheres was measured with a scale that we have at the college. We have at the college. This scale had a resolution of 0.01 grams, which is equal to 0.12301 kilogram. Okay.
Professor, that's the error, right? The what is it called? The scale error.
The scale. I don't understand your question. Can you type there in the box, in the chat box?
Okay.
Well, let's see. Let's read that again. Maybe that's what you meant, right? In this lab, I will provide you with the measurements. With measurements of the diameter of 6 steel spheres, plus the measurement of their mass. The diameter of the sphere were measured with the ruler, the vernier caliper, and the micrometer. In other words, the diameter of each sphere, right? Of each sphere was measured 3 times, each one with a different instrument. The mass of the spheres was measured with a scale, the scale that we have at the college. This scale has a resolution of, so we need to know the resolution, right? To report on the proper significant digits of your measurement. So let's, here you go. Let's summarize here the resolution of each instrument, right? The ruler, vernier caliper, micrometer, scale, resolutions. Unless I tell you otherwise, you're going to be using those resolutions for these scales throughout the whole semester, 0.00001 kilograms. Okay. Don't forget, resolution is. So I'm not sure if I answered your question, right? Who asked the question, by the way? Who just asked the question? Okay. I want to give you the opportunity to ask the question again in case I didn't answer. Okay. I do not know who asked it because I didn't have my window here open. Okay, but okay, let's continue here. Here you go. So that's the resolutions that you have to have in mind throughout the whole semester. And measurement error. No, I'm not talking about measurement error. I'm talking about just resolution. Okay. I'm not talking about measurement error, just resolution and significant figures. So the ideas that you have that we have discussed so far, ideas we discussed so far, resolution, and the significant figure or significant digit, right? Or significant digit. Either way, those are there. And now let me go to my folder here. Okay. Okay, so let's start with, I'm gonna go to your group folder and I'm going to drop a spreadsheet there. To Drive. Here is the home folder, P06, right? And I'm going to drop the spread. We're not going to have time to do everything that we need to do for this lab, okay? So, but at least you're going to have my spreadsheet there that we're going to work. Here's the spreadsheet. Let's make sure everything is fine here with those spreadsheets before I drop there in your folder. Okay, here are all the measurements. So what I usually do in my labs, right? I prepare 6 different spheres of different diameters, and the students have to measure the diameter of this sphere using a ruler, a vernier caliper, and a micrometer. And here's the data that my students prepared back then, some time ago, okay? On the top of that, they also measure the masses of those steel spheres. Okay, so notice that I have 3 different measurements for the same quantity, which is the diameter. Here we have the measurement for the ruler, the measurement for the vernier caliper, which obviously is going to have more significant digits than this one, and the measurement for the micrometer, which is going to have more significant digits than the other 2, right? And make sure everything is fine here. This one, it looks good. The other one looks good. Okay, what you see here is a table for the, you see here we have the CL here, lower bound of the CL, upper bound of the CL, right? R squared, you have to write down the R squared. But we're gonna get there. Let's see, I will walk you through step by step. And this one here. Okay. Everything's okay here. Everything seems fine here. Everything is fine. Okay. Let's try to use as much our time as much as we can, right? And now I will drop those spreadsheets in your group folder. Group 1.
Oh, so the each spreadsheets are different?
That's right.
That has contains different values.
Each spreadsheet has different data sets. Why did I put -1 here? Let me check. Interesting. I'm going to close that. Each group is going to get a spreadsheet that's different from the other group. Group number 3, group number 4, group number 5. Don't forget you need Excel installed in your computer. Group 1, do we have? Yeah, you have a spreadsheet here. Good. Group 2. Oh, wait a minute. I need you folks to change that. Do not write P06, okay? That's the format that I want for the title of this of this spreadsheet. I should have done that, but I forgot. So when you download this spreadsheet, make sure you replace P37 with P06. Okay. Group 3, Group 4, and Group 5. Everybody has their own spreadsheet there. And I'm going to go through the see the user vernier caliper. And that I'm gonna put a 2. Yeah. Which is and I want spreadsheet. I need to know if you downloaded the spreadsheet. I'm gonna ask you one by one. Did you download the spreadsheet, Tessa?
I just opened it directly like in Google Sheets.
Yeah, don't do that, right? You have to download your hard drive and run Excel while you do that. If you open in Google Drive, there are several problems. Is that because Google Sheets doesn't have all the features that Excel has. So you will need to have Excel installed on your computer and download the spreadsheet to your computer and open it with Excel, okay?
Okay.
Okay, so please download. I'm gonna put yes here. Destiny, were you able to download the spreadsheet?
Yes, I was able to
Okay.
download.
Yeah, I also need to know if you have Excel installed on your computer, right? Let me write that down here. Excel installed. You have Excel installed on your computer, Tessa?
Yeah.
Okay, good. And what about you, Destiny? Do you have Excel installed on your computer?
Yes, I do.
Okay, good. Now let's go for Gail. Gail, are you there? Gail Garcia? Oh, here you go. Oh, download and have Excel. That's good. Okay, I'm going to put the appendix here for you, Gail. One, and now we have. Okay, okay. Next is Ridwan. Okay, you have Excel and you downloaded too, Ridwan? You managed to download your, yeah, okay, good. Ashley, is Ashley there? I don't see Ashley here. Okay, next, Annabelle. Did you download?
Yes, I did.
Okay, good. Do you also have Excel on your computer?
I have the online version, the one from the
Online
school.
version? I think it's
Yeah.
gonna work. Let me know if it doesn't work, okay? Make
Okay.
sure that the online version is Excel and not Google Sheets, okay?
Yes.
Okay, good. So Norberto, did you download it? Do you have Excel?
Yeah, I have both. I was able to download it.
Okay, good. Thank you. Vanessa?
Yeah, I have Excel.
Okay, good. Camden, do you have Excel and did you download your hard drive?
Yes, I have both.
Okay. Victoria Preciado?
Yeah, I do.
Okay, thank you. Alexis, is Alexis here? No, right? Next is Marco Sanchez. Yes, you have both. Okay, thank you. Sky?
Yes, I have both.
Okay, good. Eric Martinez. Is Eric Martinez here? Nope. I have, okay. Catherine Pacheco. Do you have both there, Catherine? Hello, Catherine. I don't hear from you. Okay, I'm gonna put a star here on Catherine's name. Okay, and then let's go. Let's open this spreadsheet. We have 15 more minutes to go, so you're not gonna be able to do everything that we need. So we're going to split this class in two, right? Lab 1 in 2 classes, this meeting and the next week meeting. And let's go there, Lab 1. I'm gonna open here for group 7 since we don't have group 7, okay? So let's look step by step here. So the first table is the theoretical density of steel. Okay? And this density should be reported in the SI units. Oh yeah, well, how do we rename it? Okay, so let me help you. Yeah, first let's go back to renaming, right? I need you folks to rename rename your spreadsheet to P06 Lab 01 group, right? Group number, whatever group number you have. Do I put 2 digits? Yeah, I put 2 digits there. So it's going to be 0x, right? Whatever number your group is. And how do we do that? Well, that's straightforward, right? So here you go. I'm going to do that here in my. All you have to do is to highlight P37 and just write that down P06. Okay? I'm going to do that for everyone. So next time I already have it. Okay, P06. All you have to do is to replace P37 with P06. 1, 2, 3. So I have it right for the next time. 1, 2, 3. Okay, P37 is the other course that I teach. Okay, P06, P06. P06. Oops, cancel. Wait a minute. I cannot change that because it's open. Now I can change it. P06. P06. P06, right? Now let's reopen it. 10 more minutes to go. Okay, that's the first table. And I will write it down. 1, rename our spreadsheet to P06. Okay. Notice that the first table of the spreadsheet is the density of steel. Okay, so what I need you to do, go to the internet, and look at the density of steel. Okay. If you go to the internet, and report it, and report it in the SI units. SI units, kilogram per cubic meter. You go like that. So let's go. Internet. Density of steel. Oh, here you go, in kilogram meter cubic, right? Cubic meter. Let's take a look. Okay, the density of steel is going to depend on the type of steel that you have out there. There are different types of steel. We call it, the different types of steels are called alloys of steel, with more or less of a given other material there, of a given another substance there. And depending on the alloy of steel, the density is going to be anywhere between those two values. Ideally, I should have known what what alloy of steel that I was using. I was using that experiment. Unfortunately, the steel ball that we have there, the college doesn't say what alloy of steel we have. For this reason, you're safe to use the average of those two values here. Okay, and just report the number. Take the average of those two values and report the number here. Do not put the units here, right? The unit is already here. Just write down the number here. Okay, that's the first table. 11:52, 8 more minutes to go. Okay. So my students, they made 1, 2, 3, 4, 5, 6 times 3, 18 different measurements. 6 with the ruler, 6 with the vernier caliper, 6 with the micrometer. Okay? They have 6 different spheres of different diameters, and they reported the diameter here. For this first sphere, they got what? 1.7 centimeter diameter. Okay? But those numbers here, they are in a different format. You need to report it in the proper format with the right number of decimal places or right number of second digits, okay? Don't forget I put the unit here, and you have to fill up the units here as well. Some places I give you the units, other places you have to write down the units yourself. I'm going to be correcting your lab report based on that, based on the units. Okay, let me write that down here. It's all in the syllabus, by the way. Let me write it down. For this lab, you need to report the units of your measurement and result. You need to, 1, report the units of your measurement and result. 2, the significant figures. Measurements, the measurements, well, let's put it this way. I'm going to do it the long way, okay? You need 2. 1, report the units of your measurement. 2, report the units of your results. Okay? Report the significant. Need to report the significant figures of your measurements. You already know how to report the significant figures of your measurements. Okay. What I didn't tell you yet is how to report the significant figures of your results. Okay. I'm going to discuss that next time, how to do that.
Professor, I
Yeah.
have a question.
Mhm.
So in the density box, you have to type 7,750 kilogram meter per cubic or 8,050 kilogram
You have to take the average
average. Oh, okay, okay. Sorry.
average of those two values and report that. Okay, and so let's do an example here for the diameter, right? For the ruler. Note that what you see right in here is a format that Excel offers you to report some numbers. This format is the scientific format. The E that you see here is in reality is 10, the number 10. So what you have here is 2 times 10 to the minus 2, okay? So what I need you to do is to change the format of this number. You know, how do you do that? You go right click, format cell. Okay, note C again that this measurement is in scientific format. For this measurement and the others, I want you to change it to the numerical format. Okay, and this number is supposed to be reported in meters. Since this number is supposed to be reported in meters and your ruler has a resolution of 1 millimeter, you have to report this number up to the 3rd decimal place, just like that. Okay? So that's 2 times 10 to minus 2. is in reality 0.017 meters, which is 1.7 centimeters or 17 millimeters. Okay, everything is supposed to be reported in meters, remember? So we have to convert it, all the measurements to meters. All those measurements are already converted into meters. Do you get that?
Yeah,
Okay.
so everything is meter, right? Diameter, meter.
Everything is in meter. Everything is in the significant in the SI units.
How about the volume?
Well, it's also in the SI units, right? What's
So it's
the main
kilogram?
SI units for the volume? What is the SI? But we're gonna get there. Let's first, concentrate on the measurements, okay? The volume, we will worry about that later on, next time, okay? Let's concentrate on those 1, 2, 3, 4 columns. 11:58. It looks like we have to finish it very quickly, right? Can you do that? Okay, so here you go. For the measurement in ruler, with the ruler, we have to have 3 decimal places. For the measurement in vernier caliper, how many decimal places do we have to have? Vernier caliper has a resolution of 0.1 millimeters. You have to convert that in numerical format, just like we did for the ruler. And then you put the right number of decimal places here. 1, 2, 3, 4 decimal places, right? The numbers are very close to each other. See that? But because the vernier caliper has a better resolution than the ruler has, it reports an additional decimal place. This measurement has 2 significant digits. This measurement has 3 significant digits. Okay? 11:59, one more man. And now you should know what should be the significant digit of the micrometer, right? And how many decimal places we have for the micrometer. Okay. So I think we can stop right now. Next time we will be continue working on this table. And this table 2, you already have enough information to know how to report the proper significant figures for those measurements. Okay. And then I will discuss those results here. Those columns here is for results, right? Raw measurements are those 4 columns. Without those raw measurements, you don't do anything. You cannot do anything without those raw measurements. Here you go. 1, 2, 3, 4 columns of raw measurement. All those 3 are just results. We use those measurements to find the volume or to find those 3 different results. Any more questions?
So I have a question about the volume. Volume should be the cubic meter, right?
Yes, that's right.
Okay. And one more question. The sphere 1 value of ruler 0.017 is just like an example, right? It's not an actual like given number answer, right?
Oh, there's an actual measurement. There's a real life measurement.
Okay.
Made those measurements, and I'm really using those measurements here.
I have one more question before I go. So about the confidence level,
yeah, we're going to get there, right? I covered that last time, I believe, right? Last time or the first lab.
Yeah. So
yeah, I'm
we
gonna
have
cover
to,
it again next time.
oh, we are going to cover it again, but do we have to like use the previous video clip as a reference to do this, or are you going to like go over this and like?
Well, yeah, I'm gonna go over that. What for this specific example? Yes. Okay. You need to, in order to find the CL, you need the N and the R squared, right? And then you're going to
How
need
do
to
I
take,
find those values?
well, how many data points do you have here?
6.
Okay, so what do we put here?
6.
Well, you put 6, right? The R square, you're gonna get it only after you plot the graph. And we're gonna plot the graph next time.
Oh, okay.
Okay?
Okay.
And then you from the R square and the N, you can get the upper and lower bounds of the CL.
Okay.
Okay.
All right. Thank you so much, Professor. You're the best.
Welcome.
Thank you. All right. Have a good day.
Good job. Okay, so I see you next week.